Alright, we're doing the multiplication with decimals. I have 0.6 times 0.2. Remember, 0.6, the first number to the right of the decimal is tenths. So this is 6/10. So I'm going to look over here at my decimal grid. And the decimal grid is broken into 100 pieces. You can see there's 10 going down this way. There's 10 going across that way. So I just multiplied 10 times 10. There's 100 little squares there. So to represent 6/10, well, this whole thing going up this way would be how many tenths if I go all the way? It would be 1/10. Then this would be 2/10, 3/10, 4/10, 5/10, 6/10. And you can see clearly there's 4/10 left over here, meaning that we have 10/10 total. That's what we want. By the way, this little line here, that I should color in all the boxes, but the marker is not thick enough. So just believe me, it's 6/10. I'm going to do the same thing over here for 2/10. And instead of going down, I'm going to go across. I'm going to go horizontal. So this is 1/10. And this going across this way would be 2/10. So I have 6/10 and 2/10. Well, I'm going to put that out over here on this graph now. So I have my 2/10 going across, and now I'm going to use my 6/10. So you can see here the picture of it. What is 6/10 times 2/10? Well, we take the combination of ones that have both the tenths and the tenths from the other side. 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 boxes there. So since there's 12 boxes, I'm going to put my answer equals 12. But now these aren't whole boxes. This is just part of the decimal grid. So since there's 12 boxes colored in, and each box represents 1/100th, I get to put my decimal right here. So before we even get into the decimals, you got to remember when multiplying, the number with the most digits goes on top. So this right here, 2 times 133, you can see the number with the most digits isn't on top. So that's written wrong. I don't like that. Let's cross that off. I like it written like this, 133 times 2 with the 2 on the bottom. Yeah, you get the right answer either way, but I think this way is easier, and this is what we're more used to seeing. The second thing you always got to remember, when multiplying with decimals or without them, you have to line up the digits. This says 413 times 3. I would want that 3 underneath this 3, right? Because this 3, it almost looks like you made a mistake there, and that's in the hundreds place, when really 3 represents 3/1, so it should be over here. So this is how it's represented correctly. So again, I'll cross this off because I don't like that. Alright, moving along. Number 3, multiply like you would with whole numbers. So that example that I gave you was 6/10 times 2/10. So I'm going to use that one again. 0.6, and you don't have to put that 0 there. It's up to you. And I'm going to put 0.2, and we're multiplying these. 6 times 2 is 12, right? So I'm multiplying like I would with whole numbers. And then number 4, this is key. Place a decimal point by finding the total number of decimal places in the factors. What does that mean? So let's go back to our original example, 0.6, and I have 0.2, and these are being multiplied together. So I got 12 for my answer, and what it's saying is place a decimal point by finding the total number of decimal places in the factors. 0.6 is a factor, right? It's a number we multiply. There's one number after the decimal. 0.2 is another factor. There's one number after the decimal. So I'm going to move my decimal. My decimal starts, for those of you that don't know this, it always starts to the right of that whole number. So it starts here, and I'm going to move it over 2 places, right? Because there was 2 places after the decimal here. So I get 0.12. The product will have the same number of decimal places as the factors combined. So my product is 0.12. Right, that's the answer to a multiplication problem. And I had 2 numbers after the decimal place in my factors total. So that's how I got 0.12. Now we're going to look at some more examples here, just so you get the hang of it. So real simple now. Look at this. The numbers are lined up perfectly. I have 3 times 3. What's 3 times 3? That's going to equal 9, right? We know that. We've hopefully known that for a while. Look over here. I have 3/10 now times 3. Well, I'm just multiplying them like I normally would. 3 times 3 is 9. Now, how many decimal places are after all the factors? Well, there's 1 here, and there doesn't seem to be any here, so I just have to move the decimal over 1 place, so I get 0.9. Now, I could say 3 times 0 is 0 and add that 0 there. Either answer is right. You could include the 0, or you could choose not to. I choose not to include it in my factors up here, so just keep things easier for myself. 3 times 3, that's 9. Now, remember, there's 1 number after the decimal here, and there's 1 here. So 1 and 1 is 2. So I'm going to have to move my decimal over 2 places. So that's only 1. That would be 0.9. I have to move it a second time. And just like in addition or subtraction, when you annex zeros, you can annex a 0 here. We get 0.09 for that one, or 9/100. Here's the same thing. How many numbers are after the decimal? There's 2, and there's 1 here. Again, it's still 3 times 3 is 9, but now we're moving the decimal over 3 spots. So you can imagine what happens. We get not just 1 0, but 2 zeros, right? Because I started over here at 9, I moved it once, twice, and a third time to put my decimal right there. 0.009, or 9 thousandths. And again, we have 3 times 3 is 9 here. And then the 3 times 0 and 3 times 0 is just 0 and 0, right? So I could put those in there. And since we have 3 numbers after the decimal here and none here, I'm going to move my decimal over 3 spots. 1, 2, 3. Now, if you notice, this answer, 0.009, and this answer are the same thing. That's because we have 2 numbers after the decimal here and 1 number after the decimal here for a total of 3. And we also have a total of 3 numbers after the decimal on this one. Alright, let's look at B. It's a little bit more complex in B. We're multiplying 15 times 14. Remember, we don't ever want to multiply across like this. We want to line them up. So I'm going to line up 15 times 14. 5 times 4 is 20. 4 times 1 is 4, plus 2 is 6. Alright, add a 0 for place value. 1 times 5 is 5. And then 1 times 1 would be 1. And if I add this up, 0 and 0 is 0. 6 and 5 is 11. Carry the 1 up here. 1 and 1 is 2. We get 210. So my digits are going to be the same each time. I'm multiplying 15 times 14 here. 1.5 times 1.4. Let's just pretend that they're whole numbers. I know I'm going to get 210 because I just got it from 15 times 14. So I'm just going to write that down rather than show all the work for it. So I get 210, and I have 1 decimal, 2 decimals. 2 numbers after the decimal, so I'm going to move it over, not just 1 space, but a second space to right there. It's 2.1. And that makes sense, because if we estimate this, this is about 1.5 is, if we round it up, it's 2. 1.4, if we round it down, it's 1. 2 times 1 should equal 2. So we should get an answer close to 2.1. That makes sense, or 2 1/10. Same thing here. 15 times 14, still going to equal 210, right? So I have 0 and 15/100ths. And again, I don't have to include that 0. If it confuses you, don't use it. And here, I don't have to line up my decimals like I would if I was adding or subtracting, since all we're doing is just doing the slide to the left. Slide, you know, the cha-cha slide. Anyway, 15 times 14 is 210. So I get 210 there. And now, looks like I have 2 numbers after the decimal here, and another after the decimal here for a total of 3. So I'm going to move it over a 1, a 2, a 3. Yay! I sound like I'm pushing a toddler on a swing. So that would be 210 thousandths, or if you don't want to include that 0 there, you don't have to. You can call it 21/100ths. Now, you try this one in your notebook. Raise your hand when you're done, and please show the work. Mr. McGinnis will come around and look to see that you've done it right. So it says 9 thousandths times 4 1/10. And you can just pause the video until you're done with this problem. Alright, once you've done that problem, we have evaluate when x equals 1.43. So these are expressions, right? An expression has a number or a constant, a variable, and an operation. We can't see the operation here. That's because whenever a number is right next to a variable, what does it mean? The operation is multiplication. So, I'm going to rewrite this. 3 times, what's x? X is 1.43, 1 and 43 hundredths. That's what it tells us to do. So I have 3 times, I'm using the raised dot for my times, 3 times 1.43. And I'm going to line up, I'm going to have these lined up so it makes sense. So the top number is going to have the most digits. That's where 1.43 goes. And then the 3, even though it's really bigger than 1.43, right? $3 is bigger than $1.43. I'm going to have it lined up underneath the hundredths place. 9, 3 times 4 would be 12. Carry the 1. 3 times 1 is 3, plus 1 is 4. And I'm moving my decimal 1 space, 2 space. B, I have 0.5 times 1 and 43 hundredths. Again, the number with the most digits goes on top. 1 and 43 hundredths goes on top. 5 tenths would go on the bottom. I'm not going to put that 0 because I know I'll multiply it all together and all those numbers will equal 0. So I get 5 times 3 is 15. 4 times 5 is 20, plus 1 is 21. Carrying my 2. 1 times 5 is 5. And plus 2 is 7. And we have 1, 2, 3 numbers after the decimal, so I'm going to move this over 1, 2, 3 spaces. So it would be 715 thousandths. Your turn on part C. We have 2.6 times x. Put it in your notebook and raise your hand when you have that one completed and show one of the teachers.